Thank you, Corinne, for the wonderful presentation. I love Climate Earth, and I'm really pleased to be working with them on this project. So here I am, Chris Jones. I'm a researcher at the Renewable and Appropriate Energy Lab at UC Berkeley. Professor Dan Cameron couldn't be here today. He's flying out to Washington to brief Congress, I think, on our energy and climate problems. So just a brief agenda, talk briefly about rail, give you just a really quick overview on carbon footprint. I have a couple slides there, and then we'll talk about the project itself. What are the research questions and our expected benefits of the project. Here's Dan. I've been working for Professor Cameron for 5 years doing life cycle analysis work. Here's some of the projects that I manage at Rail. And I just wanted to mention a couple of them here. We're building carbon management tools. These are online free tools for the state of California. This is a project with the California Air Resources Board. Actually, PG&E, through the group of MBAs that are working at PG&E, they've been helping us design community pages for social networking so that PG&E as employees can actually use these carbon tools and then compare your results to others in PG&E and also between different companies. And we also have this similar version for small businesses. And Wan Young Park is a researcher in our lab who's here today. Raise your hand. He'll be working with us on the PG&E project as well. And he's been working on this database of emission factors of utilities in the United States. PG&E already provides us the data, so that one was really easy. I always like to start with this slide. This is the carbon footprint of a typical US household that comes out of our life cycle analysis work. So the blue is the direct emissions, or the scope 1 emissions that Corinne nicely pointed out for us. Here's our emissions from electricity, which are indirect after all, right? And then everything else is the indirect emissions. So we have all of the emissions from the fuel processing, those well-to-pump emissions Corinne mentioned. We have manufacturing the vehicle. We have indirect emissions from electricity production, right? So this is the part, and also from natural gas. So this is the part we're focusing on in this project, and it's not insignificant, right? This is an estimate comes out about 10% on average of direct emissions from electricity. It does vary quite a bit. Water waste, food is a big one, right? Clothing, basically, that's large agricultural products manufactured into other products, right? So previous studies have looked at these indirect emissions from energy production. They've looked a lot at the fuel processing. They've looked at storage of fuel and transportation of fuel. We're going to be extending this analysis to look at the full supply chain carbon footprint. So this is really cutting-edge research. This is the carbon footprint just really quickly in California, right? PG&E, thankfully, our emissions from electricity don't look anything like that previous slide of the typical US household. By the way, our transportation emissions are kind of off the chart. I had a little struggle with that one. So here again, the US. Now, this is the global average. Right? It's the average global household. And someday we're going to get here. We have to get here. This is about an 80% reduction from where we are. Because that's where we are today. That's the average emissions of a typical household today. We need to get 80% below that in order to stabilize the climate. Okay, so that's the scale of the problem that we're dealing with here. So this is when people start to get depressed in my presentations usually. But now here's the optimistic part, right? So for every household and for every business, there exists a set of opportunities to both save money and reduce greenhouse gases. And that's represented here on this chart. This is analysis done by McKinsey and Company. The x-axis here is total tons of CO2 per year that can be saved from all of these different actions. This is actually a total economy here. And the y-axis is dollars per ton of CO2 saved. The important part here is these things save you money, these things cost you money, right? So this is also true, of course, for PG&E. Less so for PG&E because you're doing a lot of work looking at your own efficiency, but also for your suppliers, right? These opportunities are out there. And if we can capture some of these, maybe you would take some of the savings from here and invest in doing some of these things. So you might think about how far can you go at net present value of 0, if that's your metric, for example, to reduce your carbon footprint at no cost. Now what happens here? Economists will say, well, wait a minute, these opportunities don't exist. What you're not counting is all the barriers. why aren't these things being done in the first place? Well, it could be information. Easy enough. We're going to start there. I think we can do a lot in this project to help reduce those information barriers. Just find out what the opportunities are. It could be financial barriers. Maybe there's lack of credit. Maybe just adding all of these things up isn't enough money for a supplier to really think about that's where they want to put their priorities. But we also have lack of incentives, right? So this is where PG&E can step up and say, hey, these things matter to us. If you look at your supply chains, if you look at your own emissions, and you can demonstrate that you are a greener product than your competitor, then that is now going to give you an extra incentive to reduce your emissions because you may get preferential treatment from PG&E. And that is really exciting. So what are we going to be looking at with this project? We're going to look at the full size and composition of PG&E's carbon footprint. We're going to identify what are some potential mitigation strategies of the carbon footprint, and then we want to quantify them. So that's the goal here. We've separated it into several different tasks. The first one is the scoping study. We're using the Climate Earth software, which is fantastic for this piece. The first part should not take more than a couple months that we've scheduled in the project. But then we're going to start doing some interesting things here. We're going to, in the second phase of the project, we're going to start refining the analysis. So one thing we might find, and that we expect to find, is that products that are made in California using California's energy mix, and particularly those products that are made from PG&E energy, will have lower carbon footprints than products that are made using electricity or energy from other suppliers. You may very well find out that your best suppliers are actually also your customers. So we're also going to look at transportation, packaging, materials end of life. We're going to start filling in the helmet with a little bit more detailed data. That's actually without even knowing anything specific about the suppliers yet. We're just looking at some factors about the suppliers that we already know, where they are, what they're producing, how far away they are, how you transport the products. Then we're actually going to do a survey of 50 suppliers. Climate Earth is going to help out with this. This is the piece that they put in. So that we could use data from other PG&E suppliers, put it into the Climate Earth software, and see what comes out. We're going to learn a lot about supply chains at this point. What we've really gained is a much more comprehensive picture. We've provided this new lens, life cycle assessment, to figure out where those opportunities and where the emissions exist. Then we're going to do a few case studies. With 3 to 5 suppliers, we're going to start now really drilling down. We'll have to collaborate very closely with those suppliers to do the same type of analysis that we're doing for PG&E with a few more companies that we identify throughout the project. We're going to write all of this up. UC Berkeley isn't interested really in working on a project if it isn't cutting edge. This project very much is a cutting edge project. We can learn a lot from it, not only from utilities, but from a research perspective as well. Just giving a summary of the benefits, there's going to be financial savings. They're out there. We know that they're there. We just have to find them. PG&E is really an expert at doing this with your own customers, doing energy audits. There are a lot of opportunities existing in the supply chain. We've got to figure out what they are. We're going to learn a lot about which are most efficient suppliers. Suppliers, of course, really benefit because if they can demonstrate that they're greener, we can quantify that, then we can start working with PG&E to figure out how we can improve the efficiency of the supply chain from a carbon perspective. Also, PG&E is going to have an opportunity to speak with the suppliers and understand what are the real barriers preventing companies from doing these things. And maybe there aren't any. Maybe it's simply just a matter of asking. And there'll be additional incentives, hopefully, for companies to do that. This project, it really supports PG&E's vision as an environmental leader. It's not just talk. This is real stuff, and PG&E is really taking a leadership position here. And I'm glad to see that other companies are listening. Thank you very much.